Hello everyone. So in this I will discuss three numerical of adsorption. Actually I am raising some doubts and calls regarding this last PPT of adsorption. So I will discuss these three numerical very fast. I will discuss because I am not having time and you also not having so much time. Okay, so this this is the third example. This is the bed depth service time approach. In this what we have to, this is all data given. What we have to find out is to find out the time, operating time, and a new operating time when concentration changed to 0.8. Earlier it was 0.5. So we have to find out two operating time. This is breakthrough time, you can call it also stationary or service time. This is bed depth, BD. So we will plot the graph between service time and bed depth. Okay, so this will be your graph. A graph will be something like this. It will intersect in the negative. Here is the 0, here is some negative value. Okay, so depth is given to you. T we have to find out. Okay, the C0. Okay, for B, this B part, for B part C0 is 0.8, and at that time we have to find out the T. So this is the equation for BDST approach. Ax is equal T is equal to Ax plus B. Okay, A1 will be what? Sorry, it should be A2 here. A2. Okay, A2 will be what? Your A1 into C1 or A1 into V1 by V2. In this B2, this is a B2 equation. What we will do, we will just what we will do, we will just first I will quickly tell you the steps. First you plot this graph, ST, service time versus bed depth. Okay, then you will get the slope like this. You will get, actually it should be like that, because see your intercept, here is the intercept, it is negative. Your slope you can get like this, y2 minus y1 upon x2 minus x1. Okay, like this you will get the slope you will get 270, intercept you will get minus 540. Okay, a is your slope. From here you can, so b is your intercept. So this is where you determine both of this value. Same way you can determine for next flow. Here in the question it is for this one and for this one. Okay, so this is, you have to get, you will get like this. Okay, a1 a2, this is the equation. It's easy to understand. You just put the value. Okay, for 2.5 you just divide by 2.5 and multiply by earlier how much it was, 1.5, for 3.5 and 1.5. Okay, b will not change, b will remain same. Okay, so this is how you got. And then there is some experimental relation is explained, but in the exam we are not supposed to show that, or it is okay if we not show, because it is not the part of calculation, it is just for illustration. And the fourth step is for, we will just, because we know A and B and we are required to calculate for 5 liter per day. 5 liter per day is nothing but 3.5 ml per minute. So for that we will just apply this, and for this 3.5 ml per minute flow we have calculated the A and B. X we know, this is the depth given in the question. Okay, so here I will get the value. So you can look at it here. We have calculated A and B will be the same. B will be minus 40 or 540, and this is A2 is the 116. Okay, so here this is how we get the T. And for B part, what is asked is concentration is change. Earlier it was 0.5. Okay, but now it is 0.8. So what will be the change in time? So A1, how we will get A1? Just whatever the A earlier multiply by the previous concentration divided by the current concentration. Formula shown earlier, you can just see B2, you just put the in B value and then C concentration earlier divided by concentration present, and this is you can just look at from the formula and you will get the B value. This is how you got the B, and this is the time equation, and you will just put the A and B value and you will get the new time. So this is the very simple BDST approach. Okay, this can come, yeah, this can come, it's easy. So now let's look at the next approach. Next approach is your Bohart-Adam equation. In Bohart-Adam equation, I will quickly tell you this. This is the data given, okay, and I will tell you the steps better, and then you have to practice so you will be able to understand. I will tell you the step. This is the equation. This is the equation you have to remember. So what you have to do in this, first of all, what you have to calculate, right? Okay, what you have to calculate? You have to calculate the column depth. How calculate the column depth? So column depth, how will you calculate the column depth? This is the equation, this is the equation, okay, this is equation, this is what you have to calculate. For that, what is the data you have? First of all, C0 you have, N0 you doesn't have, V you can get, C0 you can get, K you doesn't have. K, C0, CB you have, CB is nothing, your breakthrough, and C0 is your initial. Okay, so this N naught and K, these are the two unknowns you have to find out. Rest everything you can, like velocity is nothing a big of deal, you can find out. Q by A, flow is given, area is pi by 4 d square because diameter is given. So this is how you, volume is not a velocity is not a big of deal, you just have to find out N0 and K, and for that you have to plot the graph. Which graph you have to plot? Same way we have plotted in the BDST. Here your service time, here your service time, here is your bed depth. You will get a plot like this, okay. Here will be the, here is the intercept, and this is the minus value. So this is your intercept minus 540, this is your slope, okay. In the your graph you have to calculate slope like this and intercept like this. Here is the intercept, here, okay. Okay, so done. Now you know the slope and you know the intercept. Okay, what will be the slope and intercept for this? This is your slope and this is your intercept. Now you just equate this both. This is your slope is this, okay, and the slope value you know. N0, this is unknown. C0, this is, you know, it is given 600, okay, I think it is 600. V1, velocity, you will calculate velocity as by Q by A. Q is your 1.5 for first part of calculation. For first flow there are 3 flow given, so this is how you will calculate V1, okay. N0 how will you calculate, because everything is known. V1 you have calculated from here, C0 you know it is 600, so m slope you have find out from here. This is how you will get the N0. You just have to just multiply. I have just this is just a unit conversion, kg per meter cube. This is how you got the N, okay. Now N you got, now it's time for K. How you will get intercept? Intercept is equal to, as I have shown you earlier, or in the upper side, this is your C, this is your C, or intercept, and intercept is nothing but your minus 540 Okay, so how will you, so you just have to equate this C0, you know. Okay, C0 CB, you know. K you have to find out. Everything is known, only K is unknown. Okay, so everything is known. Okay, I just forgot this. C0 not 60. I just mixed this some. C0 is your 0.5. Okay, 0.5 is your C0, not 600. Okay, you just have to put this all this value and you will get the K. Once you will get the K, you just put every, because K and N, that N0, that was the no. K you got, N0 you got. Okay, now everything you got, V for here, this is where you got the, you will calculate the V. Okay, so you will get the time this way. Now in the JavaScript PPT there is a calculation for 3 data, 3 flow. Okay, so if you calculate you can similar way calculate for other flow. How will you calculate? You what you have to do, you just have to, there are for different flow, different service time and different bed depth is given. So you will get some different line, you will get some different slope, you will get some different intercept, and from that you will get a different n0 and k value. And so how will, so then you have to plot the graph. This is just like we have plotted in the physicochemical, that one, the settling velocity graph, SOR versus settling time and all. The last question in the exam was similar like that. I will tell you. How will you? So this is your service time. Okay. I think yeah. Here in this side you will put n0 or k, whatever you want. Here you put k, or vice versa, you can put either side. Okay, and for I think here it should be flow here, not service time, because a different flow value we are supposed to calculate now. So here flow, okay, like it should be 5 liter per day and all. So you will get different n value like this, you get 3 n value, 3k value like this you got. Let me show you the actual slope. Okay, this is the one, flow rate versus, okay. So you got the 3 different n value, you got 3 different slope value, sorry, k value. Okay, now you are required to calculate the for example, in this question sir has asked to calculate at 3.5 or 5 liter per day or 3.5 ml per minute. This is given. For example, sir asked in question, you are supposed to calculate at 2 ml per minute. Okay, 2 ml per minute. So in that case what we will do, you will just draw this line at 2 ml. What is the value of n0, what is the value of k, you just read that out. You just put this k and n0 value into this equation. Okay, into this equation. So this is where you got the t value for given flow. Okay, so this is just, this is the second type, or a Bohart-Adam approach. And now we will look at the first example, because this is the most difficult one, so I kept it as a last. In this what we have to find out. So this is the data given, Freundlich isotherm equation is given. In this we have to design the column. So what we have to find out, we have to just find out the runtime. Okay, from this you will be able to understand like how to proceed. Okay, for a runtime, how will you find out the runtime? Okay, this is the data given: initial COD and final COD, density, depth, diameter, depth, and this is the flow by area ratio. This is the flow rate, is KAT. Okay, now how will you proceed? You have to calculate the runtime, right? You are interested in calculating runtime. This is the runtime formula: COD adds up upon COD application rate. Application rate is nothing but your influent rate. So COD application rate is nothing but your COD influent. This is milligram per liter, and this is your flow. This is how you will calculate in kg per day. Okay, so this all is given, so you can calculate. All value is given. Next, COD adds up, because this is good, this is done. Now this is what you have to calculate. For that, this is the equation, or this is just you can simply remember from its units. So this is your weight. Okay, weight of a carbon. This is your this is saturation. So this is the weight of a carbon in a column. You can calculate by volume, multiplying volume into density. This is nothing but your volume. This is your density. Okay, pi by 4 d square, dh both is given, density is given. You can calculate the WC. Okay, so this is done. Now these two terms are unknown. So this is exhaustion x by m ratio. It is nothing but adsorbate upon adsorbent. So exhaustion would be at what? It should be around 95%. Okay, so 95% of 600 would be 570. Okay, so at 570, you just put the 570 into this equation. You will get your exhaustion x by m. Okay, so this is done. Now we have to calculate just saturation. I have shown you the calculation here. Okay, this is how you will get exhaust. Now for saturation calculation, you require 8 step. Okay, 8 step. In this 8 step, 6 first step are what? It composed of 3 table plus 3 graphs. Okay, so how will you proceed? First 2 step are table 1, graph 1. Okay, uh, table 1, graph 1. This is the table 1. This is the assumption. Okay, uh, how will you get this? You just put this c value into this equation, and you will get all this x by m value. From this, you plot x by m versus c graph. Okay, why we are plotting this? To get the c star value, because we know we want c star value. C star value is what? C star value here. This is the curve line c star. This straight line is c. Okay, so you got the c star. So first table and first graph purpose achieved. Now what you want to find? You want to find the c minus c star value. Okay, let me tell you the bottom up approach, so you will be able to recall. You are required to find out the saturation. Okay, so for saturation you require F, you require HZ. For HZ you require FW. It is given. K, it is given, but this value, this is not given. This is what? This can be obtained from the graph. This can be obtained from the graph number 2. Okay, graph number 2. This is, for that we have to plot graph number 2, and for F can be obtained from graph number 3. Okay, and this graph number 2 and graph number 3 data are taken from graph table 1, graph 1, all of this. So that is why we have to start from table 1, graph 1. From table 1, graph 1, we will get this C star, and from C star we will get this C minus C star. It is nothing, you just have to read from here. Okay, you just have to read from here at corresponding. This is first you have to fix. This is fixed, okay, because 100 is your minimum. It is your breakthrough concentration, so you have to start from 100. This is corresponding, you have to, so for example, this is 100, so from this is 0.092. So this is first you have to take 100, okay, corresponding. This is 60, okay, so this is 60. This is C minus C star, okay. So first you got like this, second, third, fourth. This is all you have to take by your own self, like 8.50. Read the value of C star. 8.2. Read the value of C star. 8.25. C star. You read all this value, and what will be your last point? Your last point will be your C concentration would be 570. Okay, at 570, read the for example, here is 570. Read the corresponding x by m value. Okay, that is all. You will prepare a table like this, and from table you will obtain this value. This is what the purpose of plotting this table. This is for our intention. So you got the C minus C star inverse value. Now what you are going to do, okay, so in the second graph we will use this C minus C star value. We will plot the graph between C minus C star inverse versus C, and what we will get, this is we will get integration part. Okay, now this is the most confusing thing for all, that how this area is calculated. I will tell you how this area is calculated. So purpose of graph 2 is to obtain this area, okay, because this area is being used for calculation of HZ. So how this area is calculated? The area is calculated by this. Here is, I have given you the, so it is nothing but you can read this value how I have minus this, and keep in mind that there are some error in the table given by the Javed sir. I will tell you what is the error. Okay, so somewhere here is some error. You can start from the bottom. How will you start? You just take the average of these two, okay, 0.67 0.067 plus 0.1 divided by 2 into, you just take difference of these two. It is what, 5 and 25. Okay, this is, you will get 2 point something. Okay, and this is what, it is cumulative, so add 2 plus this value from this, and from this you will get 2 value, 2 point something. Now you don't have to put 2 here, you have to put 2 plus earlier value, because it is cumulative, so 11, so it is somewhere, it will be exactly this value. Okay, so this is how this area is being calculated. Okay, so this, once this area is being calculated, so graph 2 purpose achieved, area is being calculated. Now table 3 and graph 3. Now what are we in what we are interested? We are interested in finding out these two value, V minus VB upon VE minus VB and C by C naught. How are you going to plot or find out this value? It is nothing but you just divide the current area divided by the final or total area. Just like for last value, the current area will be 13.8, and the total area is 13 points, so it will be 1 for last value. here we can see. So see, for last it is 1, and you just have to just divide this 1.4 divided by 13.18. Okay, so you will get all this value, and this is C by C naught is nothing but your C current C is this, your current C, and C naught is nothing but your 600. Okay, so why we are not taking up to 600 here? Because this will give infinity, that is why. Okay, so from, okay, this is, you got this two value. Now you have to plot the graph number 3. Graph number 3. Graph number 3, and this is step number 6. So this is graph number 3. C by C naught versus V minus VB upon V minus VB. From this you will get the F. Area of that graph will be F. Now how the another most common doubt, how will you get this area? This is the, for example, this is the curve. How will you get this area? This is how you will do. You just you have to do like you have done in the PV raw book. This is the area you have to calculate. Okay, now how you will do? You just divide this into the equal delta x. This is delta x, this is delta x, same delta x. Now what you will do? Now you just take this delta x, like for example delta x, you take 0.2. Okay, now take 0.2 common, and you just have to add this. Like for example, you take this middle value, this corresponding x, this corresponding x, this is corresponding x. You just add this corresponding x value. For example, this is 1 2 3. Add this 1 2 3 and multiply whole with the 0.2, because this is your delta x. So this is how we have done in the sedimentation design numerical. This is how we have performed the column test numerical and all. So this is how you have to calculate the area. Okay, so this area is nothing but your F. So once you got the F, okay, 6th step. Now the 7th step is nothing but your HZ. It is your height of adsorption zone, something like that. This is depth of adsorption zone. Yes, height of adsorption or depth of adsorption zone. So FW you know, KA you know, this area you have calculated from the table, graph 2. So you just put the value, you got the HZ, you got the F. So H, small h, it is given in the question. F you got, HZ you got, small h is given, 100 is for plus percentage. So you got the saturation. So 8th step is finished. You got the saturation. So now you just put the saturation here. You just put the saturation here. Exhaustion you have already calculated, WC. So you just calculate the COD adsorb. Okay, now you put COD adsorb here. You just got the run time. So that is all. This is how you will get the run time. Okay, so yeah, I have explained you very quickly. I have like gone very fast, but still if you are having some confusion, then you can call me. Okay.